Welcome to our channel. Hi there, my name is Ranjan. I am a full stack DevOps engineer with 11.5 years of experience working in IT. I am also a 4.5 star rated Udemy instructor teaching more than 72,000 students worldwide. On this channel, my goal is to make you learn and grow by sharing my experience. So if you like my work, then do like this video, share it with your friends, and don't forget to subscribe this channel for more such awesome videos in future. So let's get started. Thank you.
Alright, so far you already know that JPA is just a specification. When we say specification, it means it has only given how it can be implemented, but it has not implemented anything. So in very layman's term, JPA is just an interface. But Hibernate is actually the implementation framework. It has implemented all the interfaces and all the methods that is needed for doing any kind of operation. Hibernate has implemented that from the JPA interface. So Hibernate is the actual framework which does the work, does the implementation. So as we know, ORM is object relational mapping, which means that developers or people who don't know database, they don't have to worry. They just have to focus on writing their Java code and using some annotations, and then Hibernate, following the JPA specification, is going to take care of creating the different tables based on those mappings of the Java class and do all kinds of things that is needed for connecting with the database and doing all the transactions. So Hibernate is going to take care of it. But how does Hibernate does it? We don't have to know everything about Hibernate, but we need to little bit understand how Hibernate does that. So let's say this is our Java application, and here is the Hibernate framework. And Hibernate framework is also written in Java. It's nothing different. But here is our database. Earlier from our Java application, we were directly connecting to the database using the JDBC driver. And then we used to create the connection object, and with the connection object, we were getting the statement or prepared statement. And from that, we were executing the update queries or the query objects, and we were getting the data. But this was only possible if you had knew how to write SQL queries, and we were writing the SQL queries in plain string format. We were passing it. So from the database, from the Java application directly to database, and then database to Java application. But then all this was taken over by all this pain was taken over by JPA and the implementation framework like Hibernate. So in the Hibernate, what they said is just focus on the entity. Let's say we call this as entity or the class which will store the data, and the class is going to get mapped to a table in the database, and all the variables of the class is going to get mapped as a column in the table. So we said that's fine. So what Hibernate does is it takes that object that we want to store into the database, and it calls it as a persistent object. And then based on some configurations and mapping that we have given with the help of XML or annotation, it is going to talk to the database and store the data or retrieve the data for us and convert back our data to our Java objects. That's how the abstraction, the Hibernate took away all the pain that we had earlier when we were connecting directly from the JDBC Java application to the database. That's why Hibernate is called as also a multi-layered. I mean, if you see here, Hibernate is a layered architecture which helps in operate without having to knowing the underlying APIs. So we don't have to know how Hibernate does all these things internally. So Hibernate is going to talk to the database, just that we have to provide different configurations for the Hibernate for it to connect to the database. So let's see a little bit in little detail. So if you zoom through this picture, this is how Hibernate does it. So whatever entity classes we are preparing by putting the annotation at the table, at the entity, and then at the rate ID, column, different annotations we are putting. So what Hibernate does is, and then we also give the configuration related to our database. Where is the database? What is the URL of the database? What is the username, password of the database? All that we give to Hibernate. And now Hibernate is doing the magic behind the scenes. So for doing the magic, Hibernate has these six, you can say, interfaces which are working together for Hibernate. So Hibernate has these six interfaces which are working together. So there is in the interview there are questions. What are the six different Hibernate interfaces which Hibernate uses to do all the ORM activities? So ORM activities means object relation mapping activities. So first thing is configuration class, or you can say configuration interface. Here you can say configuration object. When I say interface, it's literally not interface, it's actually class only. Interface in the sense there is an interface between Java application and database. So configuration object is a simply object which has two things. One is the mapping that we provide, like all the column mappings, entity table mappings, and the database configuration that we provide in our property files. Like here is our database URL, here is our password of the database, here is the username of the database. All those configurations are getting mapped in the configuration object. That is great. So one interface is gone, or the one class job is done. Now this session factory uses this configuration. So the configuration object is used by the session factory object, and then the session factory object helps us create one connection with the database based on this configuration. So actually this session factory is going to make one connection per database with the database for us. And how it will do? It will take all the inputs that we have given to configuration, and then it will create a connection. But then this session factory is thread safe. What thread safe means? In very layman's term, I'm going to explain. Later you will know about what is thread and what is thread safety. So thread, let's say in a multi-threaded environment, let's say there are many applications running and they are trying to access one common thing at a time. So if somebody is trying to take that common thing and then somebody is trying to let's say do some manipulation to that thing. So let's say there is a variable called account balance, and then account balance shows 100 rupees. But at that time, somebody is manipulating that account balance and changing the value to 80 rupees. But at the same time, you are also seeing that account balance. So you will see 100 or 80. So that's a problem. So it is not thread safe situation. So in thread safe situation, what should happen? If the variable is having account balance as 100, then if you are seeing that value, then at that time no one can modify that account balance field, which means if I try to do a request at that time, after the manipulation is done, let's say it has become 80, then I will see 80. If it has become 100, then I will see 100. So thread safe way means session factory basically creates one object per database using the configuration class, and then the connection is basically thread safe. Okay, now we have covered configuration, which is being used by session factory, and now session factory is being used by session. So using the session factory, multiple session with this database can be created. So let's see that. The session object is used to get a literally physical connection with the database, and then the session object is used for the interaction with the database, and whatever object we want to save in the database or get from the database, we will do with the help of session object. So session object gets created from configuration object. So session object gets created from session factory object. Session factory object gets created from configuration object. But this is only one per application per database. But this can be, the session object can be multiple session. object created from the session factory. Because at a point of time, at one time we are running many queries on the database. The Hibernate is running many queries on the database for us, so it is creating many session objects for each of the database transaction. And now the next object is the transaction object. This transaction object. So what is a transaction in a very layman's term? Let's say if you are basically if you want to say that its transaction is something that is either complete or not. So what it means is, let's say I want to go outside to buy some groceries, but if it rains, then I'm going to come back. But if it doesn't rain, then I'm going to go and buy groceries and then go for let's say lunch outside and come back. So now what is my one single unit of work? Going to buy grocery, and then after that going to for lunch. If these two activities are complete, then I can say it is one single unit of work complete. That is one transaction. So when I'm coming back, then I have done both the things. One is bought the groceries, but also had my lunch. So that is one unit of transaction. But what if I am outside and I bought my grocery, but suddenly it started raining and I haven't done my lunch, which means I will also not bring grocery. I will leave the grocery and I will come back to my normal state. What was my normal state? I am back at my house without grocery, without my lunch. So this is called one transaction. So the transaction should be either complete or it should be rolled back to the previous state. So how it happens in our database world or application world? When you try to do a certain operation, let's say you want to do a get operation, select query, and then you want to do an update query, and then a save query, and then again a select query, and then an update query. But let's say the third update query failed. Then you need to roll back everything, whatever you have done before that, and come back to the state of the database, which was before you started this all operation. So the transaction management, you don't have to do anymore. Earlier, if we were using JDBC, we had to do the transaction management using the JDBC or Java Transaction API mechanism. But now Hibernate is going to take care of the database, the whole transaction activity for us. Next is we have a query object and a criteria object. So query object helps us to write SQL queries on our database. It's like normal, but you don't write it now as a query literally as select star from something, but you write the query on the entity classes, on the persistent objects, on the Java classes. And then we have criteria queries. So this is same as a query object, but here what you do is, let's say if you have to write query which is which is complex, where let's say it has a select star from where product category is let's say food, and the price range is between this and this and this, let's say or this, there are multiple and all those kind of conditions are there. Then Hibernate has provided us a criteria object. Using this, you can do a filtered select query on with where there are many conditions available. You can do all this using the Hibernate criteria object. So those were the basically 6 Hibernate classes, or you can say objects, which helps Hibernate to actually easily do the job of talking from our Java application to the database in the day-to-day work that we are expecting. But now, let's say at any point of time, the object which we want to save in the database can be in different states. It can be in the database it will be not in the database, which means it's just a Java object, or it can be it was in the database, but now it's a Java object. So how do we say that Hibernate object has different states? So let's say if we have just created an object person equal to new person and done nothing with it, and this person class has different annotations applied on it, like @id, @column, @entity, everything is applied, but we haven't done anything related, anything database operation on top of it till now, which means this particular object state is now transient. So here, if you see the definition, a new instance of persistent class which is not associated with the session. So if until the time the entity class or the class which is our model where we are actually putting the annotation about @entity, that class is, if it has not been associated with session object till now, which means the state of the object can be called as transient. Okay. Now, as soon as the state of this object gets associated with the session object, let's say as soon as you do session.save, you are doing session.save, because we know multiple session objects can be created to do different operations, and those can be created from session factory. So a state of the object can be in a persistent if it has been associated with the session. So we are saying session.save and then passing the person object that we created here. So now the state of the person object can be in persistent state. Now if, let's say, after doing this operation we close the session, we say session.close, then the persistent stay instance will become detached instance, because it is not associated with session anymore, but it can be made reattach. So if we, of course, now the session is closed, means whatever was the state of the session object is now saved in the database. But as soon as, let's say, later on we want to fetch the same object again, then we have to again attach it with the session. At that time it will become reattached. Until that time it becomes detached. So this is a small picture. So first we have the session. First you have created the object new. Then it, before it has been associated with the session object, it is transient. So here it can be just like any other normal Java class. It can be garbage collected and the memory can be removed. But if you do some operation on the transient object with the session here, then it becomes persistent stage. And as soon as the session is closed, the object becomes detached. So detached object can again become persistent if you do any operation on it, let's say update or merge or any of the operation that you do. So this is how the object state works in Hibernate. All right, we talked about the Hibernate object states: transient, persistent, or detached. So there's something called caching. So what is caching? So let's say caching is a mechanism to enhance the performance of the system. It is a buffer memory that lies between the application and the database. What does it mean? So here is our application and here is our database. Let's say I want the list of employees from the database whose age is greater than 30. So if I know those employees, this list is 2000, and I know that the list is not changing that frequently, I can basically, instead of always making a query to the database via Hibernate, I will ask Hibernate to cache it, cache that data. So it will cache it here. So whenever next time my application is calling, it is giving from here, from the Hibernate cache itself. It is not coming to database anymore. So what is the caching? It is a temporary memory which helps to improve performance when we know that data is not changing that frequently, so we can keep that in the temporary memory. So that mechanism is called caching. So caching is a mechanism to enhance the performance of the system. It is a buffer memory that lies between your application and the database. The cache memory stores recently used data items in order to reduce the number of database hits as much as possible. Exactly. So if we are not making many direct session connections from our Java application to DB, which means we are saving the number of calls, and that's why it becomes faster. So we are going to see also implement the caching as well, how it works. We will see them. But on a very high level, Hibernate supports few levels of caching. The first level of caching is at the session cache, and it is a mandatory cache through which all the requests must pass, and the session object keeps an object under its own power before committing into the database. So, as we saw, this session object maintains a cache. So, any operation that we are doing to the database, we are doing by the session object. So, this session cache is called a first level cache, and it is a mandatory cache. It is by default enabled, and all the operation happens from the Java application with the session object through the session cache to the database. That's how it works. So there is another level of cache called the second level cache, and that cache is basically not mandatory. It's an optional cache, but this cache works on the session factory level here, and this cache is shared across multiple sessions. So the second level cache works on the session factory level, and as we are creating many sessions from this session factory, which means the session factory cache is shared by different session objects, but it is not a mandatory cache, or it is session factory cache is an optional cache. And here the session is before even creating any session factory cache, it will be consulted with the session cache whether it's required or not, because as this is a next level cache, it will be shared between multiple objects. This can cause a lot of memory. It can take a lot of memory. So it completely depends whether it's really needed for a session factory cache, because it is per database one session factory object gets created. So it will be a big session, big cache. So the second level cache is this one. Then there's another cache called query level cache, and this query level cache is basically, if you see here, Hibernate implements a query level cache integrated closely with the second level cache. This is also an optional cache and requires 2 additional physical cache regions to cache the query results and the timestamp with the table. This is useful for queries that run frequently with the same parameter. So let's say here, this query cache works together with session factory cache. So this is also optional. So now, what is the use of this query cache? So let's say if you have certain queries which are almost common for all the different types of users that you have, or it has the same parameters. See, this query runs frequently with the same parameters. So let's take an example. I want basically the list of countries, all the list of countries. So we know that it is going to remain same. So that query gets cached here in the query cache. So you may or may not want, because this is also an optional cache. So the queries which are running frequently, but also they expect the same parameters and the same query to be run again and again. You can put that can be going in the query cache. Okay. So this is a small picture of how the different cache level works. Database in the first level cache, and the first level cache is the session object cache, and this is the client. So the client means Java application, which is talking to session object. Session object is talking to the second level cache, and session level object also maintains a first level cache. And then there's a database transaction. So database transaction happens via the first level cache with the session object, And then if there's a second level cache existing, it will be interact here, and then the response will be given to the application. So far we have seen different types of caching in Hibernate. Now let's talk about what are the different properties, because we said that initially the different objects that Hibernate has. One is the configuration object. So in the configuration object, we can provide many configuration. How do we provide that? With the help of property files. In the property files, we will see in the later in the hands-on tutorials, we can put different properties. Let's say one property is I'm using an H2 database, so I'm saying spring.h2.console enable true, which means I want to access this database via the URL or in the browser. So I have to make this property as true. Similarly, spring.h2.console.path h2 this. So I want to access this browser database on this URL. So if I can change, let's say XYZ, then I can access the database on the XYZ URL. So whatever is your preferred URL path, you can give. Same goes here, spring.datasource.url. Here you provide your database. Where is your database running? You give here. So here we are saying it is a file-based H2 database which is running in the same computer. Then you provide the database username, and then you provide a database password. So you provide it with the help of these properties. Now we have other configuration. We said spring.datasource.driver class name. So here the class name for the H2 database is org.h2.driver. But for different other, there are many databases from MySQL, Oracle, MS SQL Server. This value will be different, but this key will be same. So you can Google what is the driver for, let's say, MySQL database. So you will get the class, the complete package in the class name. So you can paste it here, and then you will be able to configure that for MySQL. So there's a spring.jpa.hibernate.ddl-auto. So this has property called update. This has value called update, and there's another value called create. So what happens with update? So what you want is whatever let's say in your application you have 5 Java classes, and all of them are @entity and @table. So now you know there will be 5 tables created in your database also for these 5 Java entity classes. But what if you want that only for the first time when the application starts, those 5 tables should be created, and then they should not be dropped. It should not drop. Next time onwards, only the data should get inserted or deleted, or select query should work. It should not drop it. Then you make it as update the value. But if you want every time the application stops and starts, drop all the data, drop all the table, then you make that as a create here. So let's say now you want to see what kind of SQL query is getting generated. So you can say spring.jpa.show-SQL true. So it will show you all the SQL statements printed in your in the console itself, there where you are running the program. Similarly, if you want to see the same SQL but in more formatted way, you can use this property. SpringDataJPA properties Hibernate format SQL. And there's another one called SpringDataJPA database platform equal to all.hibernate dialect, H2 dialect. Again, this is dependent on the database that you are using. Like here, like the JDBC driver, we used to have specific for a database, a specific driver. Similarly, the dialect should be also specific to the database. So this, if you say literally dialect, it literally means what is the language it speaks. So let's say if you say the Hibernate is, let's say, a translator. So if somebody in front of him is French, somebody is German, then Hibernate should know how to convert this English to the French person French and the German person German. So here, if we are using, let's say H2 database, so we have to provide what kind of so H2 database might have different syntax for writing the same select star from table name query. So if we provide this, So now Hibernate knows, okay, this is H2 database, so I have to convert the select star from in this way. So for let's say MySQL, this dialect property will be different because MySQL might have a different syntax of writing queries. So this dialect property, this property makes Hibernate generate appropriate select SQL queries, not only select, insert, update, delete queries for that particular chosen database. All right. Now let's see. If you remember in our entity classes where we do @entity and @table, we provide another annotation called @id, which means that we want Hibernate to automatically generate values for our primary key column. So what does it mean? I don't want to every time create a value for my primary key column and insert into the database. In that case, you can ask Hibernate to do that for you, but it does it in a different way. So it provides 4 options. You can say auto, which means Hibernate will select the generation strategy based on the dialect. So here, whatever database dialect you have given, whatever is the default way of generating the ID, it will use that and generate. So this is the safest way to use. Then identity, another way. Hibernate relies on the auto increment database column, relies on an auto incremented database column to generate the primary key, which means here it will do exactly same as auto, but it won't be dependent on dialect, but it will be dependent on the auto incremented database column. Whichever column you have said it is auto incremented or which is a primary key, it will use that. And then you will have sequence. Some database does not support, let's say, identity, so it's always safe to go with auto. If you say sequence, then what you can do is you can create a sequence in the database first, and then you can give that sequence here, and then based on the sequence, the primary column value will be generated. Another strategy is table. So Hibernate uses a database table to generate the sequence. Again, it's similar to the sequence. First, you will go and create a table in the database, and then use the strategy of sequence ID generation as table, and give that table details. So Hibernate is going to use that and generate the sequence or generate the values for the primary key column. The best is to go with auto. Hibernate takes care of everything. Okay. Now we so far talked only about Hibernate. Before that, we talked about JPA, and now we know Hibernate. JPA is the specification. Hibernate is the implementation of the specification. But then what is SpringDataJPA? Because we don't have to worry about Hibernate and all these steps. We just have to know what exists, but we don't have to worry about it, because now we are not using Hibernate, we are using SpringDataJPA. And what is SpringDataJPA? SpringDataJPA is an abstraction layer built on top of Hibernate to make our life easy. So what is SpringDataJPA? It is an abstraction layer built on top of Hibernate. So if Hibernate was helping us to connect to the database and do all the operations for us on the database, SpringDataJPA is an abstraction built on top of it, which means it even makes life easier for us. We don't have to worry about all this, and we don't have to worry about how it does this and this. These things we don't have to worry about, because now SpringDataJPA saved our life by adding another layer of abstraction, which means we just have to focus on writing queries. Other things will be taken care by SpringDataJPA and internally by Hibernate. So if you say SpringDataJPA, it's a part of the same Spring Data family and makes it easy to implement JPA-based repositories. This module deals with the enhanced support for JPA data access layer. So what it helps? Implementing a data access layer gets rid of it helps to get rid of a lot of boilerplate code that is needed for writing queries, pagination, or the auditing. All those is taken care by SpringDataJPA. So we just have to focus on writing queries. So we will see all this. We will see how to implement all this, and then now how to start using SpringDataJPA. Basically, SpringDataJPA provides us 3 interfaces. One is the CRUD repository, and it is purely for CRUD operations like select, update, insert, delete. Then there is another interface called paging and sorting repository, and this will help us to do all kinds of pagination and sorting things. Let's say I have 2000 products, but I want to show 20 products per page. So if you do next, it will fetch the next 20 products, so that we can implement that kind of functionality. We can implement using paging and sorting repository. And sorting, let's say if you want to sort by date, sort by product name, sort by price, you have to want to sort the result of the data. Then you don't have to write any more logic. Spring has given you interface, you implement it, Spring does it for you, SpringDataJPA does it for you. And then we have JPL repository. This is basically related to things like you want to do things in batches. So using SpringDataJPA, this normal JPL repository also you can do all the operations, but this gives you features like you want to do things in batches, then or maybe flush. Let's say flush means you want to do reset of your persistent objects. Those kind of specific functionality, if you want complex functionalities, you can also achieve it. So if you see here, this is how it is combined. So you have this repository. It has been extended by CRUD repository. So CRUD repository is extended by paging and sorting repository, and then paging and sorting repository is extended by JPA repository. And similarly, here you have different query by. These are basically to write the queries. So we will see by default, if you use a repository from Spring like this, any of these, so you get by default some methods with which you can execute queries. So we will see them. So maybe there are also different ways to write queries. So one way is to write it like this, find by field name. Let's say this is an example. So this is a repository class, a survey repository, which is extending JPA repository, and then it has survey. So now in the survey, let's say there is a column called ID. So find by ID, by default it will take the value and run the query against the primary key column. Let's say you want to write your own query, that I want to run a query by created date column, created by. Then you can run find by, just write find by and then the field name. What is the field name? Created by. So in the camel casing, first C will be capital and B will be by B will be capital. Same goes for if you want to do a long count, find by ID in. Let's say if you want to do a query which is like select star from and then where ID is in, then you do this. So there are different ways to write queries. We will see them. Similarly, there is another way to write the query. Same query is like query column. So you write a method, you pass some parameter, and then you write the normal query like query, and then you say select something, and then you write the query on the class. See, this is not a select star from, it is the class on the choice vote counts class. You are writing some query, and then similarly like this, you say select V, not star, select V from vote, which is V, where now v.user.id is equal to colon user ID. And what is this colon user ID? The parameter which has been passed here. You can pass it here. Same here. So you can basically do all kinds of join operations also. So we will see all this in the future, how to implement these kind of queries. Next thing is, let's say if you wanted to add some restrictions, if you want to add some, let's say, restrictions, then to your entity, you can use this kind of annotation. Let's say you have a name and you want the name should not be null or blank, and it should not be more than 40 characters. So you can add a max and a min of the length. So you can say @not null, @size, max is equal to this, min is equal to this. Similarly like this. and you should use all the annotations from javax.persistence. So here see all the javax.persistence annotation has been used. And for validation, like not null, in email size, you should use javax.validation.constraints from this package, all the annotations. You can also, instead of writing these two annotation, you can do the same thing like this on the name column. You just say column name is equal to name and nullable false, so it will be not null, and length you say 40, so it will be 40 characters. So this will create a query like with the column name and a varchar 40. It will be the data type, and not null will be the constraint on this column. So you can give constraint here, constraint like this. So this was a very short overview of Hibernate, how JPA works, Hibernate works, how SpringDataJPA works. All the important concepts have been now covered. But don't worry, all this we will do implementation also in our upcoming hands-on classes. All the things we will cover in detail in the hands-on.